This is a tutorial on vectors. Vectors are quantities that have both a magnitude and a direction. So they're different from regular numbers, which usually just have a size. A vector has both a size, called magnitude, and a direction. And vectors are important because they will allow us to deal with motion and other things in more than one direction at the same time. Up until now in class, we've had motion where the object was either moving side to side, horizontal only, or we've had motion where the object was moving straight up or straight down only, but we haven't had anything where the object was moving both horizontally and vertically at the same time, like that. And in order to deal with motion that is both horizontal and vertical at the same time, we need the mathematical tool called the vector. So that's the purpose of this lesson. Okay, like I said, a vector is an object that has both a magnitude and a direction. So when we want to draw something that represents a vector, we often will use an arrow, because an arrow has a size, that would be its length, and an arrow has a direction, in this case, pointing to the left. So if I walk, for example, 10 meters, actually that's to the right, isn't it? You'd think I'd know the right from my left at this point. 10 meters, if I walk 10 meters to the right, then I could draw an arrow that has a length representing the 10 meters and a direction to the right. If I walk 5 meters to the right, then I would draw an arrow that's only half as long, but still pointing to the right. And that would represent the vector 5 meters to the right. If we want to use a variable to represent a vector instead of an arrow, then we might call the vector, say, vector A. Then you write down an A, and then to indicate that it's a variable that represents a vector and not just a number, you put this little half arrow symbol over the top of the A. So you would read that vector A. And then finally, if you want to refer just to the length of the vector and not its direction, then you put absolute value symbols around it, like this. Okay, and you would read that as the magnitude of A, is how you would say that. So, for example, if vector A is 10 meters to the right, then the magnitude of vector A is equal to 10 meters. That includes just the length information and not the direction information. Well, in order to use vectors to solve problems, something that we often need to do is add two or more vectors together. So let's learn how to do that. I'm going to clear the page again. And let's learn to add vectors. Now, there are two different ways that we're going to learn to add vectors. One of them is called the graphical method, and that's where you add vectors just by drawing arrows on the page. So we'll learn that first. Okay, let's say, for example, that you are going on a hike, and you hike 2 kilometers east. Then you turn at a 30-degree angle to north. Okay, so this would be the north direction, and let's go off in this way so that we went at a 30-degree angle to the north, and we go this time 1.5 kilometers. Well, in this case, the first leg of our journey we could represent by vector A. It's 2 kilometers east. And vector B represents the second leg of our journey, 1.5 kilometers in a direction 30 degrees west of the north axis. The north axis is that dashed line, and we're 30 degrees to the west of that dashed line. Okay, now if I first go 2 kilometers east and then 1.5 kilometers 30 degrees west of the north axis, then what is my net displacement? I might, let's say I've gone on this hike, but then I want to tell my buddies who stayed behind in my original location, I want to tell them how to find me, and I don't want them to have to totally retrace my steps. I'd like to be able to tell them, how to get directly to where I am. In other words, I want them to walk like that. So the question is, what vector represents that red line that goes directly from my starting point to my ending point? That vector is the sum of vector A and vector B. So we would write that as A plus B with the two vector symbols on them. And they're equal to the sum of two vectors. We often give the symbol R, and we call it the resultant. I'm not sure why we don't just call it the result. I think it's because resultant sounds more technical. So it makes you sound smarter if you say resultant instead of just result. So this red line that I drew in that triangle, okay, that represents vector R, which is the sum of A plus B. What is vector R? What's its length? Well, if you had a little ruler, you could measure the length from this end point up to this end point, and it looks like it's a little bit less than the length of my 1.5 kilometer vector, so it might be somewhere in the neighborhood of 1 kilometer. And then you need a protractor to measure the angle, which looks like it's somewhere in the neighborhood of 60 degrees, or maybe even a little more than 60 degrees. And that would give you the value of vector R, the vector sum of A and B. Now, what we just did is called the graphical method of adding two vectors. But as you heard, when we use the graphical method, we're basically just getting an estimate for the length of vector R and the direction of vector R. It gives you a rough idea. If you need to be more precise, and you want a very specific answer for vector r, then you don't want to use the graphical method. You want to use what's called the component method or the algebraic method. So, those are two different names for the same thing, the algebraic method or the component method of adding two vectors together. So let's learn what is the algebraic or component method of adding two vectors. The first step when you want to add two vectors by components is you do what is called resolving the vectors into components. So we need to resolve both A and B into components. So the obvious question is, okay, what's a component? So we need to stop for a minute. This should be component. That's an O, not an E. So let's define component. Well, a component of a vector is that part of a vector that's parallel to one of your axes. It's easier to understand if I just show you an example. Okay, so if I draw a vector off like this, then that vector is partly in the x direction. See, the x direction is here and the y direction is here. So that vector is partly in the x direction and partly in the y direction. So when I say what are the components of that vector, what I mean is I want to separate out the x part, which is this red line right here. That's the x component of my vector. It's the part of the vector that points in the x direction, from the y part of my vector, which is represented by the green line. So I would say this red vector is the x component of the vector, and the green one is the y component of the vector. And you find the x and y components of a vector using trigonometry. So step one, when you want to add two vectors using the component method, is you find their components. So let's do that for vector A and vector B. Draw a coordinate system. Okay, and then we'll draw, let's see, here's x, and here's the y-axis. Vector A is 2 kilometers that way along the x-axis. Well, this one's going to be really easy to resolve into components, because the x component of vector A, which we denote a sub x, is just 2 kilometers. The whole thing is in the x direction. The y component of vector A is 0, because there is no part of that vector that points up or down. So that was easy. We need to do the same thing for vector B. So again, we draw our coordinate system. Here's x, here's y. Vector B is 1.5 kilometers, 30 degrees west of north. Well, that's off in this direction. Okay. So here, I'll do it. Let's do it right here. Here is b sub x, and here is b sub y. So I need to use trigonometry in order to find bx and by. This angle right here, marked in red, is 30 degrees, according to the problem. So, since this angle right there is 90, then the angle marked in blue is 60 degrees. 90 minus 30. So let's use trigonometry to find bx and by. Okay, do you remember your trigonometry acronym, SOHCAHTOA? I had a student once who told me she remembers the order of this by saying some old hippie caught another hippie tripping on acid. So there you go, SOHCAHTOA. That means that sine, so the first three means sine of an angle is opposite over hypotenuse. Cosine of an angle is adjacent over hypotenuse. And then tangent of the angle is opposite over adjacent. So, if we're going to find bx, and I know that this blue angle is 60 degrees, let's see, bx is adjacent to the blue angle, and I know the hypotenuse is 1.5 kilometers, so I need to use cosine. So I have cosine of 60 degrees, because that's that blue angle, is equal to the adjacent side, that's bx, it's what I'm trying to solve for, over the hypotenuse, which is 1.5 kilometers. So let's multiply both sides by 1.5 kilometers, and you get bx equals 1.5 kilometers times the cosine of 60. The cosine of 60 is a half, so bx equals 0.75 kilometers. Notice that bx is in the negative x direction. So bx is actually a minus 0.75 kilometers because it's in the negative x direction. All right, now let's find by. by is opposite to my 60 degree angle. So we have sine of 60 equals opposite, which is by, what we're trying to solve for, over hypotenuse, 1.5 kilometers. So you have by equals 1.5 kilometers times the sine of 60. I'll type that into your calculator. Sine of 60 is 0.87. And multiply that by 1.5, and you get 1.3 kilometers. Okay. We're finished with step 1. Resolve A and B into components. What I'm going to do is I'm going to clear the upper corner of the screen and use that to write down the answer to step 1, and then we'll clear the bottom half of the screen so we can move on to step 2. Okay, so what have we found? Well, the result of step 1 was that AX equals 2 kilometers and AY is equal to 0. BX was a minus 0.75 kilometers and BY is a 1.3 kilometers. So now we can erase the bottom half of the screen and use that to do step 2. All right, step 2 of the graphical method, or the algebraic or component method of adding vectors, is add the x components together and add the y components together. When you add the x components, what you end up with is the x component of the resultant. And when you add the y components, you end up with the y component of the resultant. Our x then is equal to ax plus bx. That's 2 kilometers plus a negative 0.75 kilometers. Our y is ay plus by. That is 0 plus 1.3 kilometers. That means Rx is 1.25 kilometers and Ry is 1.3 kilometers. We're finished with step 2. Step 2 is fairly easy. We're almost done. There's only one more step. Step 3 is use Rx and Ry to reconstruct R. It's basically the opposite of what we did in step 1. Because in step 1, we used vector A to find AX and AY. In step 3, we already have the components, Rx and Ry, and we're going to go backwards to find R. Well, use Rx and Ry to find R. How do we do that? Well, if Rx is 1.2 kilometers in the positive direction and Ry is 1.3 kilometers in the y direction, so if this is 1.25 and this is 1.3, then vector R is the hypotenuse of that triangle. If you've got a right triangle and you know the two sides and you're looking for the hypotenuse, the way to find it is to use the Pythagorean theorem. And, in fact, that's what we will do. The magnitude of vector R is the square root of Rx squared plus Ry squared. That's the Pythagorean theorem. So we'll have the square root of 1.25 squared plus 1.3 squared. We'll type that into the calculator and see how it comes out. So 1.25 squared is 1.563. Add that to 1.3 squared, which is 1.69. giving 3.25. Take the square root and you get 1.8. The magnitude of vector r is 1.8 kilometers. We also need to find the direction. The direction would be this angle right here. Since we know the opposite side, 1.3, and the adjacent side, 1.25, then we can use tangent. And I'm going to erase what we did in step 2 now so that we can use this part of the screen. Since tangent theta is opposite over adjacent, then we have tangent of theta is opposite, that's 1.3 kilometers, over adjacent, 1.25 kilometers, or theta is the inverse tangent of 1.3 over 1.25. That's going to be approximately 45 degrees, since those are both about the same. But let's see, 1.3 divided by 1.25, and then you do inverse tangent, and we get 46 degrees. It is pretty close to 45. 46 degrees. So, the answer to what is vector r, it is 1.8 kilometers, 46 degrees, and let's see, this is the east direction down here, and we're going north of the east axis, so north of the east axis. So if you went on a hike 2 kilometers east, then 1.5 kilometers 30 degrees west of north, and then you wanted your buddies to walk directly from your starting point to your ending point, then you could tell your buddies, walk 1.5 kilometers 46 degrees north of the east axis, and you'll get directly to my ending point. Okay, that finishes this lesson on adding two vectors.